Hey guys, and welcome back to Eurolink's Metric Fastener Standards Comparison Vlog Series. This is episode 16, and today we are going to be getting heavy with structural bolts. That's right, we're going all the way back to episode 4. We're going to recap some of the information there, and then we're also going to move forward with a little bit more discussion focused on the standards themselves. That whole 14399, did I say that right? Yeah, 14399 series. Right, and we're also going to touch a little bit on the hot dip galvanized ones in particularly. I wanted to hit this topic right now with because with everything going on, I do think that there's probably going to be some of that stimulus plan and everything, and future stimulus plans focused towards towards infrastructure development. That's usually where the government likes to go in order to kind of promote some economic recovery. And so I think that, obviously the big guys out there playing with the inch structural fasteners, that's going to be where the vast majority of the demand is. But for some of those European companies and things like that there could be, that are working stateside, that there could be significant demand for metric structural fasteners as well, right? So let's talk about those a little bit, okay? Now, going back to episode 4 and reviewing that a little bit, remember that your DIN 6914 is going to be your structural bolt, and that's going to be equivalent to the EN 14399-4 or ISO 7412, right? The equivalent standard for the structural nut is going to be DIN 6915. It's also EN 14399-4. If you don't know why, I recommend going back to the previous video and reviewing that, checking out episode 4 when I first touched this subject. And then also the structural nuts have an ISO standard of 7414. The equivalent standard for the structural washers are DIN 6916, EN 14399-6, so it actually does have a different EN standard, and ISO 7416. So just to recap, and I'll read them off here. Remember, DIN 6914 is going to be EN 14399. Oh, sorry, I had that wrong on my paper there. 14399-4 and ISO 7412. The equivalent standard for structural nuts are going to be DIN 6915, EN 14399-4 and ISO 7414. And the washers are going to be DIN 6916, EN 14399-6 and ISO 7416. The structural bolts in general, going back to reviewing that lesson 4 episode, are about 2 to 4 millimeters in the width across the flats greater than the normal hex bolts, right? And this allows for greater preload and all that. It's going to allow for greater strength on the bolt, right? So that, along with some of the other properties that we're going to hit today, are what make it great for infrastructure kind of projects, right? And so I've equated the 14399-4 to DIN 6914 and DIN 6915 because those are the same items dimensionally. Obviously not 14 to 15, but the EN and the DIN, right? But EN 14399-4 is actually for a DIN 6914 and DIN 6915 assembly, right? So that therefore the bolt and nut assembly, and so which means that they have been manufactured together. And I actually also hit that a little bit in that previous video as well. But again, it's just really to ensure, especially if they're coated, like with hot dip galvanization coating, where it's a very thick coating, right? That they fit and function so that the specified preload can be achieved, right? So they want to make sure, especially in those high risk projects, infrastructure projects, like for a bridge or things like that. That you want to really make sure that those things are going to fit and form properly, because especially when it is hot dip galvanized coating, there's that extra thickness there that's not necessarily there, and all that that can cause issues in the application. So I also want to mention here that the EN 14399-3 standard does have the same dimensions as the EN 14399-4. The difference is that the EN 14399-3 is those are going to be according to the HR, the mechanical properties are according to the HR scale, whereas the mechanical properties for the EN 14399-4 are going to be according to the HV scale, right? Also, the 3, so I'm just going to say dash 3, that dash 3 is going to have an 8.8 or a 10.9 option, whereas the dash 4 only has a 10.9 option. Okay, but both of them are going to have that H marking. It should have an H marking on the head, right? So, to ensure proper preload for the assembly, standard EN 14399-4 recommends a suitability test for preloading based on the standard EN 14399-2, right? So that whole 14399 series is just going to lay out very clearly exactly what is expected as far as the specifications and the testing and all of that for these assemblies, because they are so frequently used in high liability applications, right? And so because of their relatively high preload capacity and their ability to be hot dip galvanized, which provides an excellent corrosion resistance. Correct me if I'm wrong, but I think it might be the best or among the best at least. And so it's going to be great for structures that are outside in general, but it's going to be particularly great for structures that are near coastlines, right? Which the vast majority of our country is near coastline. I mean, I know some of you guys are out, in the Midwest and all that kind of stuff, not near coastline, but the majority of the people around here are. And so I'm actually going to circle back to this topic soon in a blog post. We've kind of started to touch it with episode 4. We're going a little bit more into it right now in episode 6, and then I think I'm going to put a blog post out eventually where we really dig into even more details, particularly some of the mechanical properties. So another good thing about structural bolts is that they come in a relatively deep product range, and so that's also very useful for your MROs, your OEMs out there that are trying, or your MROs out there that are trying to do repairs on any kind of infrastructure projects, because they're readily available in a lot of commercial links. So let me define that. The range of diameters actually isn't quite as large as it is for hex heads, from what I understand, but the links that are commercially available are quite impressive. That they a lot of times the hex heads, they'll tend to jump from like a 120 to a 140, whereas these DIN 6914s, they'll be like 120, 125, 130, 135, 140. You have a little bit more exact links there. And so I have a feeling this is also why it hasn't really been fully embraced by some of the big guys, which I'm definitely not complaining about. Eurolink has an awesome source for these, and we can bring them in very quickly. And I will say that we did just bring in some of the nuts and washers, and now we do have plans to bring in some of the bolts and stock them, right? So yes, your importing distributor here is branching out just a little bit and thinking of that we might stock some. We're not going to stock a lot, but we're going to stock some, and then obviously we can bring them in very quickly via air freight and all within a week or two. Or if you need a bunch, we can bring them in via sea freight, right? So that's what I was saying, is that because of that product depth and the links, and there not being as much demand, obviously the greatest demand is going to be for the inch, according to the ASTMs, like was it 325 and all of that. I'm not an inch standards guy, but that one's very popular. But yeah, that's going to. I think that's why some of the big guys aren't digging into that, but we like that one. So as a review, the metric structural bolts according to EN 14399-4 and EN 14399-6. So DIN, I was meant to say structural fasteners, but so DIN 6914, DIN 6915, DIN 6916 made for great metric options for infrastructure projects. Especially with the hot dip galvanized coating, due to their awesome corrosion resistance and high strength and hardness and wonderful product depth. So yeah, I didn't really dig into that, did I? But the 10.9 is going to be a hardened steel, right? And they take special care in the manufacturing of these to help prevent hydrogen embrittlement, because really once you start getting to 10.9 and you hot dip galvanize them, they can cause for hydrogen embrittlement. So that's why a lot of people want to go with like a 931 that's a 12.9. They're trying to get that high hardness and strength and all, and then they want to hot dip galvanize it, but the problem is that can make it really brittle. So that's why these structural bolts are these and at least the EN 14399-4 are at 10.9, and they're a little bit wider and all that. It provides that extra strength, while at the same time having that corrosion resistance. So it makes, like I said, great for infrastructure projects. As always, if you have any comments, questions, or concerns, or would like to request a quote for these items or any other hard to find metric fasteners, feel free to contact me directly at london@eurolinkfss.com. So again, that's london@eurolinkfss.com, or give us a call at 864-801-0505. Again, that's 864-801-0505. As you can see, I'm still working remotely here, so if you'd like to contact me directly, you're more than welcome to. My cell phone is actually 864-921-7388. Again, giving you guys my direct cell phone, it's 864-921-7388, right? And guys, feel free to shoot me a text message, if you have any questions or anything like that. I love to do text, right? I'm a millennial for sure. All right, guys, thank you, and continue to stay safe out there. God bless.